How do you recode variables in SDA? First of all, what does recode mean? Set that aside for just a second. First, let's set up a hypothesis to analyze. My hypothesis for this example is that people who get married young are more likely to get divorced. In other words, the age at which you get married affects your odds of getting divorced. So we have some survey questions that are relevant here. In the selected box over here, type age wed and click the view button, and you can see what they asked. If you're ever married, how old were you when you first married? And the values are just the various ages people got married at. Click anywhere, that goes away. And the second question is divorce. Type divorce in there, click the view button. If currently married or widowed, have you ever been divorced or legally separated? And you can see the relevant answers are yes or no. Click anywhere, that goes away. Okay, so which one goes in the rows, which one goes in the columns? Think about it. My hypothesis is that if you get married too young, you're more likely to get divorced. So that means age at first marriage is my independent variable. Independent variable goes in the what? The columns. Right? That's right. So type age wed in the columns, type divorce in the box, or you can just click the button over here and it types itself, and go ahead and run the table. And there's our table, and you can see that's a big, ugly table. Look at all the cells in that table. I've got a different column for each age at which somebody first got married. Some of these folks have got married way too young, 12. Holy smoke! Somebody got married when they were 12 over here at the right. Here's somebody getting married at the age of 90. Wow, good for him. The problem here is that with all these columns, the table is very difficult to read. They're very difficult to make sense of. Did people who got married young divorce more than people who married old? Well, yeah, it does seem there's kind of a pattern, but it doesn't pop out quickly. It's not easy to read such a big table. So let's kill that table. I'm going to close that window. What we're going to do is we're going to recode age. We're going to take all those various ages between 12 and 90, and we're going to break them down into two categories, young and old, to see if there's a difference between young and old. So how do we do that? Okay, after age wed, I'm going to put parentheses, open and close parentheses, and I'm going to put my recode inside that. I start a recode by putting R and then colon. In these recodes, SDA does not pay attention to spaces. You can put as many spaces as you want. So I start all recodes by putting parentheses and then putting R colon, R meaning recode. Okay, who am I going to categorize as young? Let's say people between age 12 and 30. I'm going to call them young. So I'm going to put 12-30 and then in quotation marks, young. And run the table, see what happens. You can see I get a table and there's only one category, young. Now let's build out the table. Let's make a category for old. I'm going to say to separate the recodes, you do that with a semicolon. So I put a semicolon. I'm going to say from age 31 to 90. I'm going to call that old, and I put old in quotation marks. Let's run the table again. Now you can see I've got two columns, one for young, one for old. Maybe I want the ages in those column headers instead of young and old. Maybe I want the ages in there too. So inside the quotation marks, I'm going to put 12 to 29. And inside the old, I'm going to put 31 to 90. Like that. Run the table again. And you can see the column headers have changed to reflect the changes I just made. So the rule is that anything I put inside of the quotation marks are going to be the column headers. These things over here show the ranges of the various values that I want to be in my young category. So I chose ages 12 to 30 to be in my young category. Whoops, that needs to match, doesn't it? 12 to 30. There we go. then 31 to 90. I could also pick out just several ages and separate them by commas. Let's just say I want people 12 and 14 for whatever reason. I could do it that way. And I should probably change my column header to reflect that. So it's a very simple computer language. Put that back, 12 to 30, the way it was. Very simple computer language. R followed by colon to instruct the computer that we're doing a recode. Then the various responses in the question that we want to group together. And then inside of quotation marks, what happened there? Inside of quotation marks, the label that we want for the column header. And we separate the categories with semicolons. Very easy to do. Run the table again. There it is. So I took that big ugly table with way too many columns and I condensed it down into 2-column table. Now it's much easier to read. And remember rule 2, how we read a table? We compare percentages across rows. 18.2% of people who got married young got divorced compared to 6.8% of people who got married old. So you're almost 3 times more likely to get divorced if you married young, at least according to this analysis. Simple analysis, not the last word on the topic. But you can begin to see how and why we do recodes. Let's do one more example. Okay, my new hypothesis, let's clear this all out. I'm just going to delete all that. My new hypothesis is that women are more likely to be Democrats than men are. So what's my independent variable? Women are more likely to be Democrats than men are. I'm saying your sex causes your party identifications. Therefore, sex is my independent variable and goes in the columns. So I'm going to type sex in the columns. Type party ID like so in the rows. And let's run the table. And you get this. You can see the various categories in party ID. People could respond that they're strong Democrats, not strong Democrats, independents but near Democrats, and so forth. Okay, it's a good enough table. We might be able to test my hypothesis with this table, but it would be easier to visualize if we had a table that just had 2 rows, one for Democrats, one for Republicans. How am I going to do that? Well, I think I'm just going to take strong Democrats and not strong Democrats and add them together. Anybody who says they're an independent, I'm just going to leave them out of my table. I don't care about them. Then I'm going to take not strong Republicans and add them together. In other party, I'm going to leave them out. I'll say, okay, so I've got a plan. So anybody who answers 0 or 1, I'm going to code as a Democrat. Anybody who answers 5 or 6, I'm going to code as a Republican. So let's do that. So party ID, I put my parentheses. I start off by doing R colon, and then what was it? 0 and 1 are my Democrats. So my column label is Democrats. I'm going to separate them from the Republicans with a semicolon. And what was it? 6 and 7, or 5 and 6 were Republicans. Put them inside of quotation marks. So anything inside the quotation marks is my column header. Let's run that table. And there you go. Okay, so we'll look at the table. We have a nice 2x2 table. This is called a 2x2 table because there are 4 colored cells, 2 columns and 2 rows. 2 columns, 2 rows, 2x2. Much easier to read. Remember rule 2, how do we read a table? We compare percentages across columns. 54% of men were Republicans, or were Democrats. 60% of women were Democrats. So the table seems to support my hypothesis. Women are slightly more likely than men to be Democrats. Men are more likely than women to be Republicans. We compare across that row. Okay, so that's how you recode your data. I gave you 2 examples. If you need any help with this, feel free to ask me in class. It's something that's easy to forget, but easy to do once you learn the rules, and very useful.